Hi and welcome to this intro video of my latest project, the ITX-Llama. It's a mini ITX motherboard I designed to serve as a compact, mostly all-in-one retro PC for playing DOS and early Windows 98 games. It uses a real x86 CPU, has an AGP slot for video cards, a built-in ISA sound card, many of the standard backplane connectors you'd find on any retro computer, as well as a couple of nifty features which we'll get back to shortly. First, I want to mention the heart of the system, which I kind of built this whole thing around. The Vortex 86EX system-on module from DMP Electronics. The module contains three main elements: an SoC or system-on module, 128 megabytes of DDR3 memory, and 8 megabytes of ROM. The SoC is a Pentium Pro compatible chip running at anywhere between 100 to 500 MHz with a performance of roughly a Pentium MMX 233 when running at full tilt. It also has a lot of I/O, like an ISA bus, serial, PS2, I2C, PC speaker, Ethernet, and a single lane of PCI Express Gen 1. This last one is important because we can connect that to a PCIe to PCI bridge chip and use that to drive the AGP slot. Here's a look at the backplane connectors. Starting from the left, we have the usual three analog jacks: line in, line out, and microphone in. Then there's a digital optical output, a game port to which you can connect a joystick, gamepad, and MIDI input and outputs, and a serial port. If we jump all the way to the right, there's an Ethernet port and two USB 2.0 ports. Then there's keyboard and mouse input, and you can either connect real PS2 hardware or modern USB keyboards and mice to the white USB ports. They're connected to an RP2040 chip, which translates the USB HID protocol to PS2. This has turned out to be quite a bit more stable and reliable than the usual software-based PS2 emulation you'll find in some BIOSes. Next to the AGP connector, there's a microSD slot, which is presented to the OS as an IDE drive. A couple of its data lines are hooked up to a microcontroller that provides the good old hard drive clicking sound and hard drive activity LED, both of which you can turn on and off, of course. Here you can also see the power and reset buttons, front panel I/O pins, and a SATA port for hard drives, SSDs, or CD-ROMs. There's also three separately controllable modern 4-pin PWM fan connectors, which can run at both 5 and 12 volts. If we move up a bit, you'll see the blue ESP8266 module. That's running firmware for emulating a Haze-compatible modem and can be connected to Wi-Fi, so you can call up BBSs from DOS and Windows, or you can use it as a dial-up modem from Windows if you think Ethernet is too modern. Here's the sound card, a Crystal Semiconductor CS4237B. It has a built-in OPL3 compatible FM synth and is AdLib and Sound Blaster Pro 2 compatible. And it works great in both DOS and Windows. All the resources are configurable from the BIOS settings, and all the initialization code has also been built into the BIOS, so you don't need any special drivers or setup tools in DOS. If you're a fan of real Yamaha OPL3 sound, there's also a connector for plugging in a little extra module I made, which we'll take a look at later in this video. In the top middle of the board, you have two 40-pin connectors for plugging in a Raspberry Pi running the MT32 Pi firmware. That'll give you great MT32 emulation or general MIDI using sound fonts if you don't have access to real hardware MIDI or MT32 modules. The male pins are for connecting a ribbon cable to a full-sized Pi, or you can plug in a Pi 02 directly onto the female connector, as we'll see shortly. Alternatively, you can use a wavetable board for your MIDI. The connector is of the standard wavetable header type, but there isn't enough room to plug in one of the old cards. A modern one like the S2 or X2 from Certico works perfectly though. Alright, so let's boot up the board and take a look at the BIOS settings. First, we have the CPU settings where you can set the frequency and whether to enable or disable the L1 and L2 cache. Second is the disk settings for configuring the boot order and choosing if you want the USB flash drive showing up as bootable fixed disks or not. Then there's serial or COM settings, audio settings, Ethernet, fan control, and miscellaneous settings for configuring startup sounds, LEDs, and the hard drive clicker. So let's boot into DOS. You can hear the hard drive clicker since we're running off the SD card. We'll fire up Doom with the music coming from the Crystal Chip's internal OPL3 FM synth. Here's the external OPL3 module I mentioned earlier with the Yamaha YMF262 and YAC512 chips. And we'll plug in a Raspberry Pi 02 as well. We'll go into the BIOS settings and enable the external OPL3 module. Running Doom again, this time with the FM synth coming from the external module. Granted, Doom isn't exactly the best test for comparing the sound between the Crystal and Yamaha chip. I'll fire up Fast Doom, just because I had that one configured for using General MIDI as the music source. And let's listen to the Pi. The music is too low. Now let's take a look at running Windows 98 on the ITX-Llama. I've enabled DMA mode for the SD card, which helps with transfer speeds, but it's still a good bit slower than a SATA SSD, so you might want to use that instead. This is GL Quake running at 800 by 600, and the performance is pretty good. Now for something way more demanding. Let's run Quake 3. This is pushing the system much closer to its limit, but still very playable. We're coming up to the end of this video, but the last thing I wanted to show is the digital audio output of the board. Here I'm connecting a cheap DAC from Amazon. It needs a 5-volt power supply, so I'm just going to take that from one of the USB ports. And there we go. That concludes this intro about the ITX-Llama board. Please head over to the Vogons forum for more up-to-date info about this project. I've put a link in the description. And thanks for watching.